Hi guys, in today's lesson, we're going to be solving the fifth and the final question we are given as a take home in our previous lesson on multiplicative inverse and division of modular arithmetic. We are given five major questions. We've worked on four so far, and we're going to be looking at the solution for the very fifth and final question. So if you're just seeing this very lesson for the very first time, this very question, and you want to give it a try, I advise you to pause this very video and make an attempt. So we are asked to solve minus 10 divided by 7 in modulo 11. Now don't forget, we are still working on basic operations. Once we solve this very question, we're going to be moving on directly to equations under modular arithmetic and other broad applications. So we're asked to solve this minus 10 divided by 7 to be written in modulo 11. We're going to be using two approaches. So the first is we're going to be using the direct approach, and the second we're going to be using the multiplicative inverse approach. So let's use the direct approach. This minus 10 divided by 7. Now, when 7 divides minus 10, we're going to get something. We're going to get, let's say, x in modulo 11. So that's the first method or the first approach. So minus 10 divided by 7 equals to x in modulo 11. So what I'm going to do next, the next we're going to cross multiply. Minus 10 times 1 is minus 10. 7 times x is 7x in modulo 11. So minus 10 equal to 7x, since this is an equation, it means you could swap their position. So that's going to be 7x equals to minus 10 in modulo 11. So you know what we're going to do next for those that have been following this very lesson. The next thing we're going to do, we're going to use 11 to create a table. We're going to get the multiples of 11. So each multiple we get, we add it to the minus 10. We end up having an equation like this. So don't forget we are looking for x. Once we get the value of x, that is our result for minus 10 divided by 7 in modulo 11. So quickly, let's get the multiples of 11. Don't forget multiples of 11. So that's going to be 11 times 0, 0, 11 times 1, 11, 11 times 2, we give us 22, times 3, we give us 33 there, times 4, we give us 44, 11 times 5, we give us 55, 11 times 6, we give us 66, 11 times 7, we give us 77, 11 times 8, we give us 88, 11 times 9, 99, 11 times 10 is 110. Let's stop here. So now look at the first 0 plus minus 10, we give us minus 10. So that's our first possible result. 7x equals to minus 10. Divide both sides by 7. X is minus 10 over 7. So it means minus 10 divided by 7. This is going to be the likely result, one of the likely results. Minus 10 over 7 is same as minus 1 over 3 over 7. Don't forget, whatever we're working on or whatever result we get must not be up to the modulo 11 we are talking about. So now let's try out the next. This is 11. So when we get 11, 11 plus minus 10 is 1. So 7x equals to 1. Divide both sides by 7. X is 1 over 7. 1 over 7 is bigger than minus 10 over 7. So 1 over 7 is not even up to modulo 11. So let's carry on. So what's the next? That's 22. 22 minus 10. 22 minus 10 will give us, that is 12. So 7x equals to 12. Divide both sides by 7. So x is 12 over 7, which is 1 number 5 over 7. So you're looking for probably let's say if you're going to get a whole number result. So that's 1 over 5 over 7. So let's try out 33. So 33 minus 33 plus minus 10, that will give us 23. So 7x equals to 23. Divide both sides by 7. X is 23 over 7, which is which is 2 number 14, 3 number, I beg your pardon, 3 remainder 2 over 7. So if you try out 44, what's it going to be? 44 plus minus 10, that'll be 7x equals to 34. If you divide both sides by 7, you end up having 7 times 4, 28, so that's 4 remainder 6 over 7. So let's try out 55. 55 plus minus 10 will give us 45. So let's try out 66. 66 plus minus 10 will give us 56. That's the perfect stuff we were looking for. So that's going to be 7x equals to 56. Divide both sides with this very 7. So that's going to be s equals to 8. That's a perfect result. So s is equals to 8. So 8 modulo 11. So minus 10 divided by 7 will give us 8 modulo 11. Absolute result. Don't forget, whatever answer you get must not be up to the modulo you're talking about. The highest result here should be 10 and not anything up to 11 or more than 11. So we're done with this very approach. We're going to be using the second approach, which is the multiplicative inverse. So how do we do that? Now, don't forget, for this very approach, minus 10 divided by 7 is the same as minus 10 times 1 over 7. So when you look at 1 over 7 is the multiplicative inverse of 7. So we're going to be getting the multiplicative inverse of 7. So whatever the answer is, we're going to use it to multiply minus 10. So first of all, let's get the multiplicative inverse of 7. The multiplicative inverse is simply that very number you're going to use to multiply a given number that will give us 1. So 7 times something will give us 1. 7p equals to 1 in modulo 11. So the p represents that very given number that you're going to multiply with 7. That will give us something that by the time we convert that very stuff to modulo 11, you're going to get 1 modulo 11. So let's see what that very number is going to be. So we're going to be using all the multiples of 11. So first of all, 0. 0 plus 1 will give us 1. So 7p equals to 1 divided by 7. So 1 over 7 is one of the likely multiplicative inverse of 7. So let's try out 11. 11 plus 1 is 12. 7 divided by sides. We end up having 1 remainder 5 plus 7. Let's keep going. 22. 22 plus 1 is 23. The next 33. 33 plus 1 is 34. 44 plus 1 is 45. 55 plus 1 is 56. You're going to be using this right away. So that's 7p equals to 56. Divide both sides with this very 7. So 7 divides this is 8. So that means the multiplicative inverse of 7 is 8 also in modulo 11. 8 modulo 11. That's the multiplicative inverse of 7 in modulo 11. As simple as that. So what are we going to do next? Now we're going to take this 8, we're going to use it to multiply the minus 10. So minus 10 times 1 over 7. Don't forget 1 over 7 is the inverse of this. And we got 8. 8 times 7 is 56. 56 to be written modulo 11 is 1 modulo 11. So this is the perfect multiplicative inverse. So let's quickly dive into it. Minus 10 times 8 to be written in modulo 11. So minus 10 times 8 will give us minus 80 modulo 11. So what's it going to be? Don't forget, for those that have been following this very lessons, don't forget that it's very easy. The easier way to convert a negative result to any given modulo is to assume that this very result is positive. So you're going to assume minus 80 to be plus 80. So let's convert that. So plus 80 to be written in modulo 11. What am I going to get? I'm going to get 11 and 80 will give us 77. So that is 7 remainder 3. So that will give us 3 modulo 11. So if positive 80 gives us 3 modulo 11, so what's a negative 80? What's it going to give to us? Don't forget, you're just going to take this off this. So 11 minus 3 is 8 modulo 11. So simple as that. So this is the final result. At least we got the same result. Either you use this direct approach or you use the multiplicative inverse approach. Either of them will give you the same perfect result. So we've come to the end of this very lesson. If you've gained one or two things from this very lesson, I would love you to follow me on Facebook at Revelation Hub and subscribe to this very channel at EduMosaic. And please share the lessons with others. See you in the next lesson. Thanks and bye for now.